Hello, I'm Nico Geraldo, and this is Lab 2, Lines of Charge for Physics 2. Uh, the purpose of this lab was to compare point charge and line of charge models using the charge tape divided into sections to act as multiple point charges. This is a continuation of Lab 1 and serves to improve on the results. The principles that we use are the same, Newton's second law for the force of gravity, and Coulomb's law for the force of an electric field. The results from this experiment were that the gravitational force and the electric force were equal to 2.2 e to the negative 3 newtons, and the tapes had a charge of 2.8226 e to the negative 8 coulombs. Models and assumptions. The assumptions are the same from Lab 1. Negligible air resistance, except the tapes are treated as lines of charge, and the U-tapes have the same charge as the charge is evenly distributed along the tape. The model is different as well, since the charged pieces of tape are now represented as lines of charge instead of point charges. So the experiment details, there are the same initial conditions with three pieces of neutrally charged tape, and the system is still tape A and tape B, which are both U-tapes, and the surroundings are everything else. Same procedure as last time, so I will not go into detail just to save time. Here's some data and calculations from Lab 1. This is all, I used the same data from the experiment in this lab since I recorded it very well. There's more data. This is the code from Lab 1, just showing that that's what the model looked like with a point charge. And as you can see, the charge on one of the tapes was 1.38 e to the negative 8 coulombs. This will change with the new lines of charge method. So for the new code, up here, just the constants that we were given. These are the constants, or the stuff that I found from Lab 1. And then this is the E field function that actually just makes the field. Here we can see the function that makes the line of charge, and the two lines that create the top and the bottom pieces of tape. This is the nested for loops for the superposition of the point charges to make a line of charge. And then this is the actual print statement and the code that makes the vectors. So this is what the new code makes with the lines of charge instead of a point charge. And as you can see, the charge I got is quite a bit larger than the charge I got from only using a point charge. So for the discussion, problems with the model. The tapes don't actually have equal charges, even though we assume that, and the tape has finite sections of charge. In real life, the tape will act as if it had infinite sections of charge, infinite and infinitesimal in size. And some sources of error are that the tapes did not have equal charge, and the charge isn't evenly distributed throughout the tape. Also, the charge lost due to holding the tape, that was also from one of the error sources in Lab 1. Um, for the what if and why questions, what if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So if I modeled the tape as a point charge, I would have gotten the same number from Lab 1, 1.39 e to the negative 8 coulombs, which is about 49.2% of the charge of the line of charge value, which was 2.8226 e negative 8 coulombs. Why do these estimates differ? Which value is more likely to be closer to the real value and why? The line of charge method is much more accurate since a real piece of tape is much larger than a point charge. So the line of charges is more analogous to the actual tape since it's longer than just a point.